go. Nope, here we go. All right, let's keep going. Okay, so this is something. Wait, let me make. Did I start the recording? I thought I did not start the recording, but I did. All right. Next slide here is kind of a precaution or a warning. Square roots, you can't. They're not compatible with addition. In other words, I know it's tempting to write the square root of the sum as the sum of the square roots. Don't do that. They're not equal in general. In fact, I think the only time they could be equal is if A is 0 or B is 0. But if A and B are positive, then they're not going to equal each other. I probably have made that mistake when I was an undergrad, or even in high school. I don't remember. But the square root of a sum is not the sum of the square roots. I mean, there's many examples to illustrate that. I gave one here. If you take A and B to be 1, well, the square root of 1, that's just 1, right? We've seen that. The square root of 2, however, turns out to be about 1.4 if you did it in your calculator. So on the left side, if we had the square root of 2, that's the square root of 1 plus 1. And what I'm saying is this is not equal to the square root of 1 plus the square root of 1. Here you get the square root of 2, which is about 1.4. Here we get 2. So I really hope that made sense. I'm just saying don't assume they're equal to each other. That's all. All right. Now, let's get to the wonderful midpoint formula. So basically here, if we have two different points, these 2 points have to be different from each other, meaning they can't coincide when you plot them in the Cartesian plane. And then, as I said before, you could connect them by a line segment. If you take any 2 points in the plane that are different, they don't coincide, you can always connect them by a straight line. I don't remember if that's something that's assumed to be true or if it can be proven. I don't remember, but it's true nevertheless. Then, this is the definition. The midpoint M of this line segment, by definition, it's the point on that line that satisfies this equation. Graphically, it's going to be, I didn't label the point, but it's going to be the point on this line segment, M, where the distance between M and P and the distance between M and Q are the same. What's nice is we can easily get that because we have this formula. Now this is on that line segment, and the distance between M and P equals the distance between M and Q. Essentially, you're taking the, the midpoint or the average, if you want, of the X and Y coordinates respectively. Just make sure you add. In the past, I've seen people subtract, but you're supposed to be adding. Okay, that's fun. So let's do an example. I think, in fact, we have examples. Let's do this one. So we're going to find the midpoint of this line segment where P and Q are these points. But again, it's easy. It's just that formula, which you don't have to memorize because, again, the exams and stuff are open book in this class. So 1 plus 3, right? We add the X coordinates together. That's what we're doing. We divide by 2, right? I'm just using the formula. Same thing for the Y coordinates. So we have 4 over 2 plus 6 over 2. And what we get is 2, 3. That's what we get. Okay. Good. Now, we can check. I mean, normally you would have to check that these 3 points are on the same line. There is a way to do that, but for now, let's just check by confirming this. I mean, there is something else you would have to do to make sure all 3 points are as they say. I think it's called collinear, meaning they're on the same line. I mean, you could check that by graphing, of course, but let's check this part. And that's what I'm doing here. 1 minus 2, the distance between P and M. Here's P, here's M. 1 minus 2 squared. 4 minus 3 squared. Right? So we have negative 1 squared plus 1 squared, as you can see, and that's just the square root of 2. Okay, that's good. Now for M and Q, same idea, right? Here's Q, here's M. Right? We have difference in x coordinates squared, difference in y coordinates squared. Add the squares, take the square root of the sum, we get the same thing. Good. Good. We have that check. And again, this is also, I just graphed it. I think here I actually graphed it, I think in GeoGebra. Yo, I don't know if you can, let me write out that word. G-O. Hope I spelled it right, but I think I did. But anyway, it is something you can download for free. You don't have to, but it's just what I'm using. Just didn't know if you could understand the word I'm using. But anyway, M you can see is on the line connecting P and Q together. So I know I drew more of the line, but really all we care about is the line segment from P to Q. Okay, so we have that. Okay, well, let's do another example. Let's now suppose P is this point and Q is this point. So first, we're going to get the midpoint, right? And again, it's just the formula, right? You add the x coordinates, divide by 2, right? Okay, we have negative 1 plus 4 over 2, which is 3 over 2. Same thing with the y coordinates. We have negative 3 plus negative 2, right? Negative plus negative 2 over 2. So that's negative 5 over 2. And we get this. This part we don't have to do unless I ask you to, but I felt better doing it. I figured it's good practice with the distance formula. But hopefully you can see that, yeah, that at least the distance-wise is the midpoint. I mean, normally, again, you would have to check that it's on that actual line segment, M. M is actually on that line segment from P to Q. We'll see that shortly, though. But anyway, again, it's just the distance formula, right? Subtract the x coordinates here, squaring. Then you subtract the y coordinates, squaring, right? Again, it doesn't matter what order you subtract because we're squaring. So we have negative 2.5 squared plus negative 0.5 squared, okay? This is actually minus a negative. That becomes plus. So maybe that's not the best way to write it, but we get this. Same thing with M and Q, same idea. We have 4 minus 1.5 squared plus negative 2 minus negative 2.5 squared, right? We got the squares, we add, then we take the square root. Again, it doesn't matter what order you subtract. You know, I did 4 minus 1.5. I could have done 1.5 minus 4 if I wanted. But, you know, it doesn't matter. We did graph it, right? This is a better picture. This I actually drew through Desmos, although I think I've showed you that before. But you can see M is, yeah, definitely on that line segment. So, okay, that's fun. All right, I mean, that's it for 2.1. I'm not done teaching yet today, I mean.